let us see now how to solve this question. A CPU has 16-bit instructions and 6-bit addresses. There are two types of instructions. Type 1, 2 address. Type 2, 1 address. If there are 12 2 address instructions in the system, then how many 1 address instructions can be designed in the system, can be formulated in the system? This is the question. If you can have a look at, this question is somewhat different from the question what we have solved so far. Okay. Now let us understand how to solve this question. Okay. Now let us see what we have got in the question. What are the details provided in the question? CPU has 16-bit instructions, right? So instruction size is equal to 16 digits. I will write it here. Instruction size is equal to 16 digits. Okay. And there are two types of instruction. What we'll do is, I will draw one more block diagram for this instruction because there are two types. Okay, which is also equal to 16 digits. These two types of instruction are different in the number of addresses that they contain. Type 1 has 2 addresses, type 2 has 1 address. Okay, so type 1, let's have a look at this. Type 1 has 2 addresses, that is address field 1, address field 2, and opcode field. You know that the opcode field should be common because without an opcode, we can't design an instruction. So type 2 has just one address, remaining all opcode. Remaining all the digits will be for opcode. Okay. Now let us see how many digits are assigned for opcode, address 1 and address 2. Let us have a look at. There are 6-bit addresses. As you can see, there are 6-bit addresses, meaning one address is equal to 6 digits. Meaning address 1 will take 6 digits, address 2 will also take 6 digits. Address 1 field will take 6 digits and the address 2 field will also take 6 digits each. Okay, then 6 plus 6 is equal to 12, which leaves 4 digits for the opcode digits. 4 digits for the opcode field rather. Okay, now here I do have a 4-digit opcode and 6-digit 2 addresses. Total is equal to 16. Right? Now, the question is, if there are 12 2-address instructions in the system, how many 1-address instructions can be formulated? That is, type 1, this is type 1. Type 1, 2 addresses, 2-address instructions are equal to 12. There are 12 2-address instructions. If there are 12 2-address instructions, how many 1-address instructions can be there? That is, type 2, which are equal to 1 address, are how many? We need to calculate and count. Let us have a look at. See, how many 2-address instructions are there? There are 12 2-address instructions. Right? Now let us have a look at this opcode. This opcode is of 4 digits, right? Opcode is equal to 4 digits. A 4-digit opcode can give you a maximum of 16 combinations. 2 power 4 combinations is equal to 16, right? But here look at, there are just 12 2-address instructions, meaning total 16 opcodes are possible. But are we consuming all the possibilities? Are we consuming all the opcodes? No, just there are 12 used. Okay, each instruction will take an opcode. So out of 16, 12 are used for 2-address instruction. Opcode will give you 2 power 4 possibilities, that is from 0000, 0001, 0010, so on to 1111. Total 16 combinations, out of which 12 combinations are used for to address instruction, that is type 1. Okay, which means that the remaining 4 combinations I can use for type 2, right? The remaining 4 combinations in the opcode, first 4 digits, I can use for type 2. Now have a look at. When it comes to type 2 has 10 digits in the opcode. Type 2 has 10 digits in the opcode. Now, the thing is, but the 10 must be divided into 4 plus 6. Because in the type 1, in the first 4 digits, 12 combinations are already used. So what we do is, we will take the remaining combinations in the first 4 digits and all the combinations in the next 6 digits. Because this is the first time we are using this one as an opcode. Okay, this is the opcode in type 2 instructions. Earlier, this was an address pad. So this is the first time we are using this one as an opcode. So this will give us total 2 power 6 combinations, right? So all total 2 power 6 are available to construct type 2 instructions, in addition to 4 leftover combinations from the type 1. So the total number of opcode that are possible for type 2 instructions is equal to total type 2 instructions are equal to leftover combinations in the first 4 digits that are equal to 4 into the total combinations in the next 6 digits, that is 2 power 6. The total combinations in the opcode field, the first time as we are using this one in the opcode, total 10, but 10 must be, opcode is equal to 10. The 10 must be divided into 4 plus 6, because in the first 4 we do not have all the combinations available. Only 4 combinations are available. In type 1, 12 combinations are already used in the first 4 digits. So in the first 4 digits we have just got 4 more combinations. So that combinations will take, okay, this will be multiplied with the total combinations of this next 6 digits, which is equal to 2 power 6. So the total number of type 2 instructions will be equal to 256. This is the answer for this.